While I was pen casting the elimination method example in the previous video, I figured I might as well do another one. So here's another example. We want to find the solutions to the linear system where the first equation is x plus 4y minus z is 12, and the second equation is 3x plus 8y minus 2z equals 4. Okay, so we're going to start in much the same way. We're going to first eliminate x. Okay, so eliminating x, I took the first equation and I multiplied by -3. Now I'm going to add these equations together so you see the x's get eliminated. And as before, we end up with -4y. And this time we're going to get plus z. And now if I do this subtraction, I get -32. Okay, so now I set up an equivalent system like I did before. So here I have this equivalent system where I replaced one of my equations with the new equation, minus 4y plus z equals -32. And I have the one of my original equations. This is the equation x plus 4y minus z equals 12. All right, so now I'm going to try to eliminate y. But what happens? So at this point, to eliminate y, I would just add these equations together. But when I do this, I will also eliminate z. There's no way around it, because I can't help it, right? I have to. All right, so let's do that. Okay, so we do our elimination, we get x, and we have these guys cancel, these guys cancel. So all we're left with is -20 on this side, and so that is one of our new equations. I meant to write it in green. Sorry, I will box it in green. Okay, and so again, we're left with an equivalent system, which I'll write out on this next slide. All right, so here is my equivalent system, and I can no longer eliminate any variables. So I know that x is just stuck at -20. So in every possible solution, the x-coordinate of that solution, or the x variable, I'll have to substitute in -20. But there are a lot of ways that -4y plus z can equal 32. You know, if I stick 0 in for y, then z is just -32. And if I stick 0 in for z, then y is, I guess, +8, right? So there are already two solutions. So how do I handle it when I have multiple solutions? So here is the notation. We're going to use, we're going to parametrize, which should be familiar from Calc 2. So we're going to parametrize the solutions. Okay, so what that means is I'm going to write it like the solutions are. So these brackets denote a set. So I'm going to have multiple numbers in these brackets, and that tells me I've got a set of solutions. So x is -20. That's always the part of the solution. I'm going to let y equal t, and I'll tell you what t is in a second. And then if y is equal to t, we could solve our previous equation in terms of z, and we would get that z is 4t minus 32. Okay, and for t, I can let t be any real number. So t is a real number. That's one way to write it. Okay, so let me break down this notation for you. So the brackets just mean the set of all, right? And then this line here is, so you'd read, so it's the set of all, x equals -20, y equals t, z equals 4t minus 32, and then you get to this line and you read it as such that, or satisfying the condition that, and then you continue reading, t is a real number. So here I have infinitely many solutions. I have one for every real number t. Okay, and you may find yourself in a situation where you can only eliminate 2 variables, but you're working with 4 variables. So you might have 2 variables that can be any real number. So you might have an s and a t. But when you write up your homework, I hope that you will use this parametric notation because it's nice and it sets up what we're going to do later on with matrices.